Welcome. My name is Kyungbum Lee. I'm the Dean of the School of Engineering at Tufts University, Carroll Family Professor, and a faculty member in the Department of Chemical and Biological Engineering. I'm delighted to open this special event held in collaboration with representatives from the Lawrence Livermore National Lab and the Fermi National Accelerator Lab today. Today's gathering exemplifies our ongoing collaboration and shared commitment to diversity, equity, inclusion, and justice in engineering and the sciences. I'm glad you're all able to join us today online. Before we dive in, I'd like to go over a few housekeeping items. Please note that the chat function will be inactive, but the Q&A option will be available for you to ask questions later in the program. Also, this event is being recorded and will be made available online in the coming weeks for those unable to join us in real time. We have a lot to cover, so let's get started. Each year, the School of Engineering at Tufts welcomes exceptional guest speakers to Tufts to deliver lectures and have conversations on topics that inform us and enlighten our community, and enhance our conversations on the critical topics of diversity, equity, inclusion, and justice. Our DEIJcolloquium speakers are renowned leaders in their fields. They've included executive officers of NGOs, national leaders, college presidents, and an astronaut as well. They're national and international experts in a wide range of topics in engineering, with an additional focus on the importance of diversifying STEM fields. Today's speakers are no different. They will share their insights as part of the Voices from the U.S. National Lab series. This is part one, focusing on experiences and initiatives at both Fermi and Lawrence Livermore Labs in the respective locations. Thank you once again for being here. I would now like to turn the visual mic over to our official host and moderator, Professor in Civil and Environmental Engineering, and the Associate Dean for Inclusive Excellence, Professor Chris Swan, to introduce the speakers. Chris, take it away, please.
All right, well, thank you, Kel. I appreciate you opening this up for us. And so let me get going. I want to get going as quickly as possible. For those who don't know me, I'm Chris Swan. But what I'm really here about is welcoming these three panel members that we have here today from the two national labs. Our first panelist that I want to talk about is from Lawrence Livermore National Laboratory, and that's Marisol Gamboa. She is the Computing Workforce Manager at Lawrence Livermore, where she is responsible for overseeing the organization's workforce planning, hiring, and recruiting activities. She has 20+ years of technical and managerial experience, including assignments supporting the National Ignition Facility and global security. She has led software teams, been a principal investigator, and had several roles in line management. Marisol was co-director of the Data Science Summer Institute, a member of the Lab Science Education Program Advisory Council, and a member of the Diversity and Inclusion Committee. Marisol earned a BS in computer science from the University of New Mexico, where she was a first-generation college student. We are also excited to have two representatives from the Fermi National Accelerator Lab. First off is Jennifer Chekalu. She is a mechanical fluids engineer at Fermilab, where she specializes in the design of cooling skids and the maintenance and operation of fluid cooling systems. She plays a vital role in the design of cooling skids for the Long Baseline Neutrino Facility, which are critical for cooling key equipment. Jennifer holds an MS in mechanical engineering from South Dakota State University and has been a mechanical fluids engineer since 2019. And last but not least, I would like to welcome our third panelist, Lucy Nobrega, a principal engineer at Fermilab specializing in ultra-high vacuum design for particle accelerators. She currently leads the vacuum group of the PIP2 project, Fermilab's new linear accelerator based on superconducting radio frequency technologies, and manages fabrication, procurement, and clean room groups. Lucy holds an MS in mechanical engineering from Illinois Institute of Technology and has been specializing in vacuum engineering since 2001. So while we are virtual, I would like for everyone to please join me in giving a warm digital welcome to these three wonderful panelists. Okay. So now I'd like to embark on our major piece of work today, which is a panel discussion. And I'm going to be asking a series of questions. And in doing so, I would like to have the panelists answer. While we're doing that, please put questions. The audience can put questions into the Q&A as well, and we'll get to those at the end. But the first part, I want to begin talking about the labs themselves and about what the panelists actually do at these labs. So let me throw this at Marisol right off the bat and say that in general sense, can you tell us what happens at the Lawrence Livermore labs, what its functions are, and what are some of the efforts at that lab? And then could you briefly describe some of the projects that you are working on? And then we'll rotate other members.
Sounds great. Thank you, Chris. So Lawrence Livermore National Lab has been around for over 70 years. We apply science and technology to make the world a better place, a safer place, ultimately. We are located about 60 miles east of San Francisco, California, just to give you a little bit of an idea. And we apply cutting-edge science and technology to achieve breakthroughs in nuclear deterrence, counterterrorism, non-proliferation, defense, intelligence, energy, and environmental security. So we are a Department of Energy national lab, one of 17 across the country. So for me in particular, like Chris mentioned earlier, my career started at Lawrence Livermore National Lab as part of the National Ignition Facility. And we are really privileged to have, thousands of projects ongoing across the lab. So after a couple of years there, I moved over to global security, where I've served the large majority of my career as a computer scientist. I did start as an individual contributor on a project that has been around, well over 50 years. And we were at that point in time pushing the envelope on what we called unstructured data management. Now, the new name for it is data science. But in the early 2000s, we didn't call it data science. And we didn't have data science degrees. So a computer scientist as myself was, writing algorithms, developing the technology that needed to support the science and the scientists that were involved. I've like Chris said, I've moved through my career and I've served on multiple projects. Most of the projects that I've led as a principal investigator have actually been for the Department of Defense around counterterrorism. And my learning experience, always pushing technology's envelope, having requests from Department of Defense asking, can we solve this problem? Can we solve a future problem? Can you look even further into the future to solve problems we don't know about? So for me, my career at the lab has always kept me on my toes, has kept me learning. Every time I mastered a skill, I was ready to learn 10 new skills, and that's what the sponsors demanded of us. So I have to say that I often got to pick and choose the problems that I like to tackle and the technologies I like to learn. So really at a national lab, it's really up to the individual and where their passion lies and where they want to take their career. And you can choose the mission you want to support along the way.
Thank you very much. Jennifer, can I ask you the same general sense of questions about what the Fermilab is about and what you get to do on those projects?
So Fermilab is actually a neutrino research facility. Basically, we study science, advanced particle physics experiments and research. That's what the lab pioneer at. And currently I'm working on the project, the long baseline neutrino facility that the lab is building and is actually intertwined with DUNE, which is a deep underground neutrino baseline that neutrino research that is also being built in South Dakota. So this LBNF will actually is a research facility that will be built in Fermilab, Batavia, and we have the superconductors and physicists that we are working with that will be building this facility here in Fermilab, Batavia. And these experiments will shoot out neutrinos all the way almost 800 miles to South Dakota, where it's being studied by the Dune facility there. So basically my project on the LBNF, I'm a mechanical engineer, and my project is on cooling of horn systems. These horn systems, they are like they focus these particles such as the neutrinos and other particles that come from the experiment, and this emits high energy that will have to be cooled, if not can damage the system. So we have the magnets, we have the horn systems. So basically my field is mostly to design cooling skates that will cool these systems to make sure that it's to ensure its longevity and to be able to run smoothly in operations. So apart from the projects, I also get involved in operations, and Fermilab currently we have different experiments that we run daily from day to day. And these projects are also being managed by some engineers and some technicians. We work every day with each other to make sure that we are managing the systems, we are fixing, we are troubleshooting on a day-to-day basis. It could be leaks, it could be when systems are down or when we need upgrades on old system, because the lab, we have some old system that we needed to update and upgrade. So we kind of look for ways to better design newer systems to make it more efficient and effective as well, especially when they tend to break down a lot. So these are the kind of things I do on the, on my day-to-day work, but I mostly concentrate on fluid systems, and this involves fluid simulations, writing up engineering documents, preparing cost estimates for what's needed to design a skid. And then I work directly with technicians, designers, and this is my first 5 years of engineering, and it's actually very interesting because every day we don't do the same thing. We always you always come to work, you kind of experiment on things and you learn new things all the time. And the lab also offers varieties of projects if you want to get involved with. Like I was talking to one of my colleagues the other day, and we're actually discussing like how broad, like you come to work, we don't you don't do the same thing every day. Like tomorrow, if I want to go into structural engineering, I can easily do that, or any part of engineering I feel comfortable, because it's so broad that we have different aspects of mechanical engineering that works on different projects. So yes, that's
Beautiful. Thank you. All right. And Lucy, I know you work at the same lab, but I'm curious to know what differences you have. So
the biggest difference is we work on different projects. So I'll take it back a step and say that Fermilab is a research-only laboratory. We're centered primarily around particle accelerator technology, and Jennifer works on our flagship project, which is LBNF, and that is neutrino research. And that is just fascinating stuff. We also accelerate electrons, protons, muons in different machines. I work on the PIP2 project primarily, so I have some other operational duties, but PIP2 is the new front end for our accelerator system. And that's based on superconducting RF technology for really efficient acceleration. And this uses cavities that are cooled down to 2 degrees Kelvin, which requires some huge cryo plants. But yeah, so we do that. And so we create the beam, accelerate the beam, manipulate it, and study it. And each of these parts of the accelerator have different technology associated with them. So for accelerating the beam, we use the superconducting RF cavities that I mentioned. To manipulate the beam, we use magnets. To steer the beam, focus it, defocus it toward our experimental areas. And then we study the beam with instrumentation. And that's basically what we're all about. We also do have a new quantum lab that's made some significant advancement in partnership with quantum industry leaders. And then we have other collaborations worldwide. So we helped build the CMS detector at CERN in Switzerland. Actually, it's half Switzerland, half in France. And we have a remote operations center for that. My role is PIP2. I'm a level 3 manager for the vacuum group in PIP2. So we make sure that the machine operates down to about 10 to the minus 10 millibar, if that means anything to you folks. So primarily that role involves keeping the cost and the schedule online, doing some engineering tasks, and then leading my group. And really what I see as my primary responsibility in this role is making sure that the people in my groups don't have any roadblocks to their tasks or their success in general.
Thank you. So my sense from hearing all of this is that you have abilities, let's say right now, that involve not only the technical aspects, but also the organization and management aspects of working at these labs. And so I'm curious, especially for the people that I interact with, which are mostly students, what happened when you first began? What sort of project, or basically what sort of work did you have when you first entered into working at these labs? And so can I go backwards here and start with Lucy and come back around?
Sure. I designed supports for the accelerators. So for different magnets and instrumentation devices, and I reported to a more senior engineer. I did a lot of CAD work. I did a lot of interacting with various groups, our alignment group, our machine shop, our technicians, and learned everything I could from those folks because they were truly the experts in the field. And I don't know, anyone who's designed a lot of components knows to talk with your technicians and find out what worked before and what didn't.
Excellent. Jennifer, what was your first task when you entered into Fermilab?
So my first task was when I first came, my first year, I started with designing ejector prototype. It's like a prototype for the LBNF. It's like on a smaller scale. So for the LBNF, we are designing an ejector loop on a bigger scale, right? Because we are cooling almost 1.2 megawatts heat flow, and we're going to be using these ejectors, but we wanted to start small to make sure that this could work. So I had to design a prototype. So when I did that, I did that with my supervisor and a senior engineer that I worked under, and I did design that system and it did work out great. So from that, we scaled it up to the main LBNF system that I'm currently working on to make sure this the system requirements aligns with what we're doing. So yeah, that's what I started with. And so it's kind of like starting small on a prototype and it's kind of scaling up it up to the real system as well. So yeah.
Marisol.
So as a computer scientist and starting at a national lab, like I said earlier, my first job was at the National Ignition Facility, which is 3 football fields largest laser in the world. So I was part of a larger team that wrote all the software for all, the hardware, all the way from a very low level code all the way up to the UIs that the operators actually click on the buttons. So I was part of a larger team. I was assigned one of the UIs that I'm proud to say are still shown in the videos that they show when they talk about the largest laser. I tell my children all the time, I wrote that. So it's really amazing to be part of a larger team, have a team collaboration, know that even though you're fresh out of your university, you're not left alone. You have guidance. You have, like Lucy mentioned, those more senior people that came before you. You can talk to them and ask them what the mistakes were made, why the decisions were made to move forward in the fashion that we're moving forward. And for me, most importantly, the contributions you make at a national lab, even as a computer scientist, are important and they live on. That's why I can say that 20 years later, I see the UIs that I wrote, on videos. Now I don't work on that work anymore.
So now I'm curious about how long those projects that you got to work on, how long you got to work on them, and at what point did you have the ability to transition from them or to actually take other opportunities? So I'm wondering, what's the duration of a project that you want to be working on when you first entered versus now being a manager and operator?
Yeah, so for me, NIF obviously is still around today, but the work that we do in software can be short-lived, right? You can choose to stay on. I could have chosen to stay on. I still have coworkers that are there supporting the National Ignition Facility. But when I reached a level to where I had fulfilled the requirements that were given to me, I chose to take another assignment in global security. There's work for everybody, right? There are people who like to master a skill in a language and continue to apply that and develop that even deeper. There are those people like myself that are shiny new objects. So I chose to go and chase the new technology that didn't exist yet. And I literally spent the rest of my career chasing the new technology that was coming out. So for the projects, there are very long-term projects like National Ignition Facility, and there are very short-term projects. I also worked on a lot of proof of concepts, like Jennifer noted. And in software, those proof of concepts could have taken 6 to 9 months. And then we delivered it to a sponsor, and then they tried it out to see where they wanted to go next for more full-time funding. And at that point, there could be 6 national labs working on a proof of concept, and one of 6 gets selected to move forward, right? So the range of projects can be very long term, 20, 30, 50 years, or very short term, 6 to 9 months. But I think as you progress in your career and you become a subject matter expert in something, that's when your projects get shorter and shorter. And your expertise is sought. But again, we all have a choice to where we could stay on those long-term projects if we chose to do so.
Great. Jennifer, similar?
Okay, so for me, when I first started, the ejector prototype project that I was designing was, I think I did it for a year and a half, and it was kind of delayed because of the COVID. I started working with Fermilab in December 2019. So shortly after that, we had the COVID. But then after that, when like I said, the prototype was just something we're looking at so as to see if it will work on the bigger scale, which it did. So we're applying that same concept on the bigger scale. But the bigger scale, which is the LBNF project, it's a long-term project. And that project has, before I came to the lab, engineers have been working on it for like, I think the person that retired that gave me most of his project said he's been working on it for almost 11 years before he left. And I'm still seeing that we're gonna keep working on it for the next 10 to 15 years. So it is a long-term project, the LBNF. Then I also have other smaller projects that I work on, because sometimes you want to just get out of this project and kind of spread your wings to kind of grab into new concepts as well. So I do other smaller projects in operations, like updating skids, like the old skids in different building and facilities that we have, different experiments, like the Meson experiments. I manage some of the systems there, and we are upgrading some of the piping and fluid systems in the Meson experiments. So such things could take between 1 to 2 years, depending on the funding and how big those projects are. Some of those projects are just very small skids. Some of them are bigger skids. Some are just piping that we need to change, and you have to work with technicians to make sure you're designing the right piping system and all that. So yeah, it actually depends on the scale. So for smaller scale operations projects, we're looking at between 1 year to 2 years, sometimes 3 years for a bigger operations. But like, yeah, those are kind of the timeline.
Okay. Great. Lucy, any difference? Lucy?
Oh, sorry. I can see here that my internet connection's a little unstable, so hopefully it'll hold out.
Okay.
So yeah, one of the things I want to latch on to that Jennifer said, it is actually really nice to be working on a couple different things, because not only are you exposed to different projects, but they're usually at different stages of development. And yes, they take years around here, depending on the size of the project. And those we'll start off in different phases. So first you're doing, when an engineer comes on board, you already have a primary concept, right? And then you move forward to preliminary design and then final design, procurement, installation, commissioning phases of the machine. And then it gets turned over to our operations teams. So obviously a lot more effort is required when you're designing, purchasing and building a machine than when you're actually operating it. So some folks will stay on and continue to support those particular accelerators, and others will move on. And when we move on, sometimes it's at the end of a project, and sometimes it's because your particular skill set is needed more elsewhere. I found that in my experience, I was always given a choice on what I would rather do. And that has actually really meant a lot to me. I do feel valued here. So it's been really rewarding to do this, and also to have kind of a choice over what my interests are, what my future is. So I went into vacuum engineering. I switched over from structural at some point because I liked it.
So this is one of the pieces I wanted to get into. We've talked about so far what you're doing today and how you got there, so to speak. But I also want to talk about how you got there, not just the process of learning new things, but also the opportunities and you being able to take them. And while you mentioned that, I wanted to get in with all of you to talk about the opportunities for job growth and progression, even within the lab itself. So I want to begin that by saying that I mentioned earlier your degrees, and introducing you, I mentioned earlier what your degrees were, but what sort of additional education have you been able to do while at the labs? And I know that some of that additional education probably was technical, but there's also a professional and a management side of development that needs to be done for any employee. So I'm wondering if any of you, all of you, can speak to those opportunities that you have seen during your time at the labs. And start with Marisol. Sorry.
Yes, so like you said, being in a technical field, you always are learning something technical, and some of that learning requires taking a course. I know my first job out of college, my curriculum was in C++, and I had to support a Java application, so I was sent off for a 4-day training and then came back to a full-time Java app, and it works, right? It works. But overall, to develop my career, the lab is super supportive of education. One thing that we have is an education assistance program where the laboratory actually funds up to 2 graduate level degrees, actually 2 degrees in general, any degree you'd like to choose to further your education, fully funded through the National Lab. But something I did have to do to develop my career, something I didn't touch on earlier, but I'm currently the computing workforce manager. I've been that for the last 3 years. So my role at the National Lab changed drastically when I took on that role, right? It's no longer looking at software, lines of code, managing technical teams. Now I'm looking and overseeing, a large body of employees and making sure they have what they need and removing those obstacles so they can accomplish their goals. So some of the early training that I took, which was key to me as a first generation Mexican American woman, was Latino leadership training. And actually Lawrence Livermore National Lab offered that, and it was by choice that I took it. But it was very enlightening to understand that coming from the culture that I came from and coming from southern New Mexico, very large demographic of Hispanics, that my culture was different than the environment I was walking into, and that my culture in itself, the way I was raised, could potentially inhibit my growth if I wasn't aware of it. So I learned things like my culture taught me not to brag about my skills, right? Which is not good. We all have to state the quality of our skill set, right? That's part of our resume and really important. But those are the kinds of things that I learned there that were critical to my career growth for the next 20 years. Other things that I did was I did a management certificate program at one of the local universities that positioned me well to lead others, right? How to communicate clearly, how to understand people's skills, and most importantly, how to leverage people's passion, right? And I heard Lucy say she always had a choice, and I think that's what I've always felt like I had a choice where my managers leverage the things I was passionate about and offered me more opportunities to work in those areas. And I wanted to be a manager that did the same, right? So that was critical to my career growth. And lastly, but super important, I also took an eCornell certificate on diversity, equity, and inclusion. And for us at Lawrence Livermore, diversity of thought is so critical to solving a hard problem, right? You have to see the problem from different avenues, and diversity of thought, not just race, is critical to identifying the gaps in the solution before you get further down the road, before it's too late, before you deliver a product with issues or gaps. So all of those have helped me immensely to grow as an individual person, and to be able to lead and advance when the time came, and also for others to see me and offer me opportunities when I wasn't looking, right? When I was busy working on something that I was super passionate about, others were still advocating for me as well.
Thank you. That was great to hear. Jennifer, do you have any? I mean, you've only been doing this for about 5 years now, so I'm just curious as to what sort of trainings, what sort of additional education you've been receiving.
Yes, the lab has been very supportive in both technical education and professionally, even the social skills, leadership training, which I've had as well. With the lab, have offered the Emerging Leadership Development Program. It's called ELDP for, the newer engineers that will be getting into leadership or managerial roles in the near future. It's kind of a program that will sort of prepare you on how to be a better leader or how to be able to contribute more as a leader or a great team player to your organization. So it was very educative to kind of look at things and they teach about like emotional intelligence on how to communicate more effectively and how to be a great team player for your organization and your people that you're working with. So it was something that you don't always learn in school. It's something that, because when we leave school, you just enter the workforce. Like there's this kind of education, social skills education that we don't feel is necessary, but it's really important to learn how to navigate people skills, basically, to learn how to navigate and work with your team to, build better workforce, and learn how to communicate and also learn how to work better with people, So those are like the things that are very important that the lab brought to our attention and was very educative because you don't always learn such things when coming out of school. And also the other technical skills that we learn, the lab has been very supportive is, I've done trainings on the AutoCAD, PNIDs, because I work with that a lot in my projects. And we also have training on the ASME B31.3. Those are piping code, like the American Society of Mechanical Engineers, piping codes, engineering codes. I concentrate mostly on the piping and the pressure vessels codes as well. So these are the things the lab has also tried to make sure that we are well versatile in and well trained in as well, because we use this in our everyday work and design and projects. So it's been very helpful, and these are the things that I can always apply from day to day as well. So the lab has been very educative. There are other aspects of the lab that if the DEIA, the diversity lab, the diversity group in our lab, they have these trainings we do every month or so. We have meetings on various aspects of the diversity inclusion, such as the LGBTQ meetings. We do that here. We have the Black Society meetings here as well. The Fermilab Young Engineers, we have meetings like, so like there is no group you wouldn't see basically in Fermilab. So, you know, I receive emails like sometimes I don't have time to go to all of them, but like the ones you have time to go, you just have to attend. And even the lab also has the Society of Women Engineers, because I actually was employed through Society of Women Engineers when they came to the conference in 2019. So, and then we have a group here, so we meet, and, you know, things like that actually help us when we meet. We go to these meetings, we try to connect, we try to make sure that, you know, we see what's happening. We don't feel alone, you know, actually as a Black woman, and or even not just as a Black woman, like as a woman in the engineering field, and being new in the engineering field, sometimes you need to connect to know the kind of things your mates are doing. Okay, is it okay to change what you're doing? Is it okay to switch? Is it okay to talk to your supervisor about this project or about these issues? Is it okay to, how much level of influencing can you do in your organization? You know, so these are the things that matter, that we kind of get to talk about and discuss with each other when we meet at these various meetings, such as the one I last went, Society of Women Engineers. We just did an annual conference in Chicago here in the McCormick place. It's the largest women engineering conference. I don't know if any of you attended, but it was very educating. We had a lot of sessions and panels that were kind of addressing, you know, workplace and how to navigate workplace, how to, you know, be a better leader, how to, you know, manage your work and your projects, and how to be a great influencer. You know, these are the things that are really important that could take it to the next level. These are the social skills that we tend to, you know, apply, that can take you to different levels, because, you know, we think that people's skill doesn't matter, but those are the things. You may know your work, you may know your project, like the technical part, but being able to connect and communicate is also as important as well. So yeah.
Great, thank you. Thank you very much. Lucy, I want you to have a chance to chime in as well on this question about what additional education you receive.
Sure, absolutely. So I've taken some additional vacuum training courses through the American Vacuum Society and other locations. And one of the things about that is, in addition to the professional development courses that Jennifer mentioned, which Fermilab does offer quite a few of, we're able to go out in terms of our own specific job function, because we do such specific and segmented things around here. We've got subject matter experts in various areas. So if you wanted to find a quality control or some kind of an FPGA class, then find one, suggest it to your supervisor, and usually they'll pay for it. So whether there's travel involved or not. So we've done that. And then just leadership development. There's another leadership development that I did that's called LWISE, and that was a collaboration between Argonne National Lab, Fermilab, and University of Chicago. And then just going to other conferences. So we brought an International Operation of Accelerator Vacuum Systems, OLAV, to Fermilab this last year. And so that was an excellent experience. But yeah, lots of different opportunities, and yeah, there is also a program to allow students to take classes at university to get degrees.
Well, thank you all for being very open and candid about what your labs offer. Now I want to talk about what got you there. So now I want to get into the education that you pursued. I mentioned all your formal degrees before, and I was wondering, how difficult was it, or how easy was it to get that degree? And what was your greatest barrier that you might have experienced while pursuing your graduate or master's degree? And with that said, I'm going to switch it over to Marisol so that she gets that opportunity.
All right. So I did mention that I'm first generation Mexican American. I grew up in a very small farming community. My graduating class was of 60 total. I did, I believe something in my background set me up to succeed in STEM because I played baseball since I was 5 years old. My uncle was our coach. That's why I was allowed as a female to play baseball. I was well taken care of. Played all the way through Little League. So early on in baseball, you're one of five women, girls, and then by Little League, I was the only young woman playing. And I was exposed to computers first because there were no computers in my town when I was growing up through the New Mexico Supercomputer Challenge, through a Telnet terminal, which I'm assuming a lot of people don't know, but I'm hoping some will know what a Telnet terminal. It was through a dial-up modem, an old-fashioned phone line that you plugged in the wall. So that's where I found my passion, and I call it my superpower. But I went on to get a bachelor's degree in computer science, and that's where I stopped. I went into the workforce. I actually was one of three females graduating class of my computer science class back then in the early 90s, late 90s. Um, and and I have to say that in hindsight, I would encourage everybody to seek a master's, a PhD program at that point in time. I did not. I didn't think about pursuing, graduate school, but I should have, and I didn't. But some of the obstacles coming from the background that I came from was in my education was actually not the female to male ratio in college because it seemed normal to me because of the playing baseball. And I guess you don't understand these things when they're happening to you as a child, but you realize them later in life that you're fully comfortable in a male dominated environment because of these things that you experience growing up. But the biggest obstacle for me was actually a language barrier. So English is my second language, and I went to college and I had a very difficult time with English class, the simplest class, right? And also becoming from a small town, I guess just the education in English wasn't as focused as my math was. I excelled at math, and I believe that being English is my second language. I failed at English. I did exceptionally at math. I was, a calculus tutor from my freshman year in college. And I excelled in computer science. And also, I didn't see that language gap in computer science. I was able to master that skill. And throughout, my career, I've been fortunate that we can learn all the time. So I've had many a help. I write many presentations, many papers, now have no problems with the English and writing a simple paper. But that is an obstacle, and throughout my career it has showed up, and being aware of those obstacles or anything that holds you back personally, right? Being aware of them and having advocates and people that can mentor you, that can advise you along the way, that can just tell you, you know what, that paper sounds perfectly fine. That's just you and your own thoughts getting in your way. But I didn't see, I know a lot of women like to say that or experience a difference being a woman in a male dominated field. I didn't feel that. And I think it really stems back to when I was young and grew up playing baseball with all the boys, and I think maybe I developed coping mechanisms, or I was fully aware of how to function in that environment. I can't say it ever held me back, it ever was an obstacle. On the contrary, I believe that's why I rose to be a leader before some of my colleagues with PhDs did not rise to be leaders, because I was outspoken enough to represent my team and to hold my ground when we needed to hold our ground, right? And because I did lead experts in the field, and sometimes people need more validation than just being an expert, and I was able to provide that. But I do believe that that one thing did set me apart from the rest, both male and female colleagues, and it really taught me how to stand up for what I believe in. Chase my passion, because I believe if we all can chase that passion, find something to work on that we're really passionate about, we will be exceptional at that job by nature because we enjoy it. So
Great, thank you. Lucy, do you have any great barriers or lack of great barriers during your pursuit of your degrees?
So I don't know if it was luck or if I just kind of went through and went like a stream that was, you know, just turning at every opportunity and, you know, okay, there's nothing here, then I'll just go there. So my experience through my work was it kind of guided my path. So first I started out as a drafter at a machine shop to pay for college, scholarships and all that. And then I worked at a consulting firm on internal combustion engines and a gas company for fluid flow, and it was kind of all over the place. I studied knee replacements for my master's research in an orthopedics department at a hospital, and before I came to Fermilab. And times were different. I mean, we didn't have role models. We didn't expect role models. We took advice where we could get it. Some of the best advice I ever got was from this just hardcore PhD student, and I gave a presentation and it wasn't what I expected, and I was apologizing for my slides and you know, kind of got through it, and she pulled me aside after it and she said, "Don't you ever apologize in front of a group again." And she said, "Women do that way too much. Don't do that again." And I never did again. It was great advice. Not to say you should never apologize. We're not always right or wrong, but yeah, that's one of the things that we women love to do is apologize. But yeah, part of what guided me, my dad told me I didn't have to go to college, and because I was a woman, and so I'm stubborn enough that motivated me to go to college, and I got my master's, and here I am.
Thank you. Jennifer.
So yeah, a little about me is I actually come from Nigeria in West Africa. So I did my bachelor's degree in mechanical engineering. So while growing up, I never envisioned to be an engineer. My parents always told me I was gonna be a doctor because I always did well in school. Part of the things of nobody really looks at a woman as an engineer. So if you're intelligent as a lady, you have to be a doctor. So, but I didn't like biology. Like I was concentrating on math, physics. Like I was so good at those, and biology I was just trying to get by, you know. So, but then after everything, I went to college. I did chemical engineering. I actually chose chemical engineering because I was like, okay, at least if it's not mechanical, my parents would be like, oh, they don't want you to be carrying hammer or stuff like that. Like, you know, they feel like you're gonna work in an auto shop as a woman, so you can't be a mechanical engineer. So I went to chemical engineer, at least maybe I could work in a gas company, or because Nigeria is one of the highest producing in oil and gas in Africa. So most of the females, we go towards chemical engineering, so you end up working in an oil refinery or something. So that was what my father wanted me to do. So since I was going towards the engineering part, but I've always wanted to go towards the mechanical. I always wanted to be a mechanical engineer because I love the idea of the physics behind it, and, you know, inventing things, and, you know, working on cars or just designing piping systems and things like that. I worked on mostly equipment design when I was a chemical engineer, which also had to do with some part of mechanical engineering. So when I was looking at masters, I was like, you know, I want to do mechanical engineering. And given we didn't have the funds where I was coming from, I did apply to schools in the US for funding and scholarships. And I did get into South Dakota State University as a graduate teaching assistant, which covered my tuition and also pay me stipend to stay. So when I came to the country, it was easy for me to transition. Basically, let me say I came to America with only $500 in my pocket. So I'm also a first generation college student graduate in my family. My father stopped at primary school. I don't know what they call primary school here. I think primary school, like people at the age of 10 to 12 years, that age, like that's when my dad stopped school. But my dad always told me he was the best in class. My dad was also smart, but his family didn't have money, so he didn't have the opportunity to go to school. My mother stopped in high school. She graduated from high school. She didn't go for that. So like basically, and I'm the only one in my family that has done masters too. So, but my siblings, did go to university. So basically we are the first generation in our house, but my parents ensured we went to school, you know, given the resources we had back home. So on coming here, I knew I couldn't afford the school. So I thank God I got the scholarship through graduate teaching assistantship, which scaled me through my master's in mechanical engineering. It was also tough because I was transitioning from chemical to mechanical, and most of the courses we had, like stress analysis, although it was very interesting learning them, because as masters, we are doing the advanced level, right? Because I can remember most of my classes advanced stress analysis. I was like, we didn't even do, I didn't even do the basic one, like the advanced, the mechanics before you go to the advanced mechanics. So I saw myself, I had to get the textbook from the undergrad. I self-taught myself the whole textbook because the first day we had our lecture, the professor gave us series of assignments, like almost 20 questions that had to do with undergrad, because he wanted to kind of remind us of what we did in the undergrad. I was like, I didn't even do this course. So I saw myself studying. I can remember I went to the library for a whole week. You know, I was at the library for a whole week. You know, I spent more than 10 hours in the library because I wanted to finish that textbook so I could answer those questions. So those were like the barriers that I had transitioning from like chemical engineering background to mechanical, and I was doing the master's. And as a master's student, being a graduate teaching assistant, I was also the graduate teaching assistant for the thermodynamics class and the dynamics fluids class as well. So I'm the one grading these students, so I have to know what I'm doing. You know, I have to make sure. Some of them come to me, I'm like, oh, why did I fail this question? Like, tell me the right way to do this. I'm also in their labs to kind of guide them what to do. So I had to make sure I'm on top of what I'm doing. I had to make sure I had to go back to study and, you know, make sure that I could answer their questions and things like that. So those were like the motivating things, because I was like, I have to get my degree. I know I couldn't afford, I have to keep my job as a teaching assistant. I know I couldn't afford to pay my tuition. So those were like one of the pushing factors to make sure that I did well and I kept my scholarship and I graduated, you know, from school. So which was, I graduated, it took me 2 years, which was normal standard time it takes to get your master's from from most schools here anyway. So upon graduation, that was when I came to Fermilab. So I graduated in December 2018, but I started in Fermilab in December 2019. And between that, I was at 3M in Brookings. I was working as a machine operator there before I got my position in Fermilab as an engineer to start working on this. So, you know, along the way, I've always been motivated because my dad has always told me you can do anything. Like, and, you know, I've always been someone that likes to make sure I cross all my T's. I make sure that even if I don't understand something, you know, I ask questions. I know some people sometimes in our field of work, you don't like to own that you don't know something. Sometimes you feel like, oh, if I ask question, it's going to be like, I don't know this, but I'm like, no, you're not supposed to know everything, you know, like just ask. Like, I can remember when I came to school, one day I was working on an assignment with one of my classmates. So he's from I don't know if it's China or something, but one of the immigrants, because we were some of the immigrants that came to school, and you were also on assistantship. So whenever I'm teaching him stuff, he's like, Jennifer, like, are you sure you didn't do mechanical engineering in bachelor's? He didn't believe I was coming from a chemical engineering background. He was like, how do you know this stuff? How do you know this stuff? I'm like, you know, like, it's not like I know everything. And when I came here, we didn't have any application or mostly computer simulations. We didn't do any of that in Nigeria because we don't even we don't have any applications. Like the institutions there is not as advanced as in the US. So I had to learn all the applications, like all the computer and most of them were self-taught. And the professors in our lab in the school, they don't go back to start teaching you stuff in undergrad. So you have to basically self-teach, go and research and teach yourself these things. So those were the barriers that I faced here. And I can remember sometimes I'll be crying, I'll be like, I don't even know if I can take it any longer because, I'm here, I don't have any family. I have to figure out how to eat and cope on my own, So those were like the major barriers that I had. And, I just kept pushing. Every time I talk to my mom and dad, they always like, tell, where you come from. You have to, make sure you can't just stop now. You have to just continue, and and it's paying off, and whenever I look back, I'm like, I'm glad that I came here. I'm glad I didn't give up. I knew some of my friends that even come from Nigeria, at the point they dropped out. They're like, they can't continue, they can't do this. They went back home, and now they're not in a better positions because things that they're not much jobs that they could fall back to, or like because of they didn't complete their career, or their career didn't get to the level that they could have wanted, and scaled to the level that they could have wanted in the career because they didn't finish, so because of the barriers they had here as an immigrant, is kind of, and first generation also coming from outside the country, you don't, people here are different. You don't have family here, and you have to cope, get housing, know how to eat, take care of yourself. So it's a whole different level of support you need. So it's not everybody that could do that well, given that kind of environment. But I'm glad I pushed through, and with God's help, also with the funding I got from the school, which really helped me stay throughout the course of my career and, having a job here. So those were like the major barriers that I faced, but I've always known that I could do it. I've always believed in myself. That's one thing that I've always known. Like, I've always known that I was special. Like, I know that I could do this as far as I put in my time and my work and ask questions. Like, I'm not afraid to ask questions. That's the thing. Like, even if I'm someone that is shy, that I don't like to bother people sometimes, but that's not the case when it comes to technical stuff, that I don't want to make mistakes. I know I can learn from someone, and I like working with people that know what they do, like experienced people. Like when I came to Fermilab, I was working with some people that have been here and experienced. Like I always go to them and ask them questions. I won't want to ask them stupid questions. I don't care how stupid the question is, but as far as I'm going to learn from it, I want to ask that question. I want to make sure I have that resources and, help that I need. So yeah, don't be afraid to ask questions. Don't be afraid to think that, oh, someone is going to feel like you're stupid or you don't know what you're doing. But, that's what I have to, yeah.
Okay. Well, thank you, all of you actually, for being so forthright and honest on that particular question, because I think it is important for us to recognize what things are in our way and how we can overcome them. And so I enjoy the fact that you were able to actually express that so that our audience could actually see it and also think about it from their own perspective. But I'm also aware of the fact that we are at our time. So with that said, I would like to thank all of you for being basically here for this wonderful presentation and sharing your inspiring experiences with the audience in total. And basically, I want to conclude our event today. So thank you for attending, all of you out there, for attending the school's DEIJ colloquium. Please be on the lookout for more diversity, equity, and inclusion colloquia in the very near future, including the next events in this particular series. So with that, I close off. Thank you all again.